Lots of sensors means that autonomous vehicles will have no avoidable crashes. So the fact we have sensors means they'll see things and they would never hit something that's physically possible to avoid. That's a myth. The way robotaxis and other autonomous systems work is that they have a perception system that builds a world model. The real world is out there, and some sensors sense that real world. There may be video cameras, probably multiple of them. There's a LiDAR, which is like a light-based radar that some vehicles have, and there's actual radar. All those things have different views of the world. They have different strengths and weaknesses. They have different capabilities. A typical robotaxi, for example, will have all of these modes of sensing and maybe some more. They take all those inputs, and then they use a machine learning-based system to run a perception system which says, okay, that camera image coupled with that LiDAR image, coupled with that radar image, means that there's a child kicking a ball out in the middle of the road. And they build a world model saying, yep, sure enough, there's a child chasing a ball into the street 10 meters ahead. Okay, that's important. Now what do? Well, we have a path planning and motion control with some prediction that says anytime there's a ball going into the road with a child in proximity, we're going to assume the child is going to chase the ball and we're going to stop whether or not we see the child right now, because we know that the ball is going to be followed and we want to avoid getting into a bad situation in the first place. Or less aggressively, oh look, there's a child on the road, I think we need to stop. This works if you actually take the video and LiDAR and radar and realize that it's a child and not a picture of a child or not a bush or not something else. So while you can have a lot of sensors, the real magic is happening in the perception and prediction to turn that sensor image into a model of what's really happening in the world. You'll hear some companies say we're safe because we have lots and lots of sensors and our sensors don't blink and they see 360 degrees all the way around the car and they see all these things and that can be true, but that does not necessarily mean they're safe. Sensors is only the first part, as you just saw. Once you have a camera image and a LiDAR image and a radar image, then you do sensor fusion, which is, well, the camera sees this and the radar sees this and the LiDAR sees this. They're all presenting somewhat different images. What's really going on? The sensors might disagree. They might have different opinions as to what type of object it is. But the idea of sensor fusion is to take all those sensor inputs and say, okay, there's a thing there based on this sensor information. And if the sensors disagree, you have to figure out which ones to believe and which ones not to believe. And maybe you get that wrong. Then there's perception and prediction. Okay, I see a thing there. Is it a child? Is it a bush? Is it a shadow? Is it a picture of a child? What exactly is it? And there is a non-zero misclassification and misprediction budget here. These systems are not perfect at classifying objects, especially in between objects, like a person walking next to a bicycle might be a person on a bicycle. It might be a person riding a bicycle, which have different behaviors and therefore will have different predictions of what happens next. What if there's a planning control fault? You might have perfect sensor fusion and perfect perception and prediction, and your planning logic just gets it wrong. Yes, that can happen. In March 2023, a robotaxi hit the back of a city bus, and there were no extenuating circumstances. There was no reason for it to do that. It saw the bus. The sensors all saw that there was a bus there as far as we know. And the explanation was, well, the tracking logic said, I see a bus, and this particular bus had a joint in the middle. It was articulated. And the tracking logic decided to follow the front half of the bus and basically ignore the back half of the bus that was right there. And so it ignored the back half and it ran into it. Simple as that, straight up logic defect, to the point that a recall was issued in April to correct that defect. The moral of the story is just because a sensor's there and the car sees the object does not mean it will do the right thing. Cars have software. Software has bugs. Automated vehicle software will have bugs that hopefully are eliminated before volume production, but that's a possibility that can't be ignored. The takeaway is that sensors are important, sensors are great, but sensors aren't enough. Perception and prediction are also critical for safety.